Hi everyone, my name is Jan. Today I want to talk a bit about internationalization and taking your apps, websites, whatever, global. I want to start with an apology. I set the slides to be themed from Aladdin, and this morning I got to see the new trailer and it looks completely scary. The new Aladdin movie that Disney's coming out with. So just 2 seconds about myself. I'm the Director of Engineering for WeWork Technology, which means that I work for WeWork, but I work with technology at WeWork. Back in Tel Aviv, we have a small office of about 180 engineers, product managers, designers that work on all sorts of different problems for WeWork. WeWork deals with a lot of scale, as you heard earlier. We've just celebrated our 100th location. Just 3 years ago when I joined the company, we had barely 40. In December, we opened 61 new locations around the world. We hired 80 new engineers all across the world. And we're working in a whole suite of different problems. From how do we operate building new spaces and build apps for interior designers so they can optimize the furniture that they pick in the locations. How do we give members the best tools to manage their presence in the space that they are in? Tools for community managers who operate these amazing spaces and communities to know what's going on, what music is playing, what types of event people want to see. All the way up to knowing where people are in a location to know maybe to drop down the AC if there's too many people in the common area, or maybe we need to turn down the music because people want to listen to a conversation. We have engineering sites in New York, Tel Aviv, San Francisco, Shanghai, Singapore, Seattle, and Salt Lake City. So if you're located in any one of them and interested in learning more, hit me up. Before WeWork, I used to work at eBay and PayPal. And at PayPal, I got to work on a cool little project called the PayPal mobile app. We had a team of about 12 engineers in Tel Aviv working with about 120 all around the world, launching the redesign, rebuild of the PayPal mobile app. We had the chance of starting from scratch. There was really like new iOS app, new Android app, no legacy code base, which was really exciting. But the challenge for us was how do we launch an app that had to target 26 different languages, 140 different markets around the world. And the team in Israel was working on the P2P, sending and receiving money, which when you start combining the different subflows with the different currencies and countries that came into play, meant hundreds of different combinations to make sure that it worked correctly. And so today, this is what I want to talk to you about. How many people here launched an app or website or service or anything that had user interface? Great. How many of you did it for the US market or Israeli market first? Okay. How many of you had to take it globally after it was successful? How many of you wanted to die while doing it? Yes. So today we'll cover the basics about what it means to take your app global, what you can do to make it better ahead of time, so when you have to launch in all those different markets, it's just not as painful. And first, let's talk about why you would want to do that, right? So when you look at people's usage of the internet, according to a survey in 2017, only 25% of people online use the internet in English, which is kind of crazy, right? It's a stat that I had to go back and verify because it looked weird to me, but it means that people around the world want to see the internet in their language. They're not like us developers. They're not fine with English. They want to see it in Hebrew and Chinese and Russian, in whatever language they want. And so if you don't get the chance and launch your application in whatever market that you're targeting, chances are someone's going to be stealing your food. Some local competitor will come up with a shittier solution, but will be there in the local language and will take your business. Some other cool statistics. So 6% of consumers want to see information in their own language. And it's even extreme. In China, 95% of users expect to see services they use in Chinese. And that's not only in Eastern countries. If you go to Europe, 90% of Europeans never browse in a language other than their own, which is pretty insane when you come to think of it, especially when you look at the trends of who uses the internet and how much, and you understand that English-speaking countries are going to be a minority not so far in the future. So hopefully I've convinced you that it's worth taking the effort to localize and make your app fit whatever local country. And these are the wide gamut of things we're going to talk about today. So let's start with G11N. Who here knows what G11N stands for? Globalization, that's great. So as you notice, these words are very long, and so to make it easier to write, the very basic is, I forgot the word for it, but take the first letter, last letter, and then just count how many letters are in between. You might know it from internationalization or I-18N, a very long word. Internationalization stands for taking your app and making sure that you can make it fit other markets. So taking your app that you built for one specific market and making sure that the code, the product, the design is ready to accept other locales, other concepts. The flip side of internationalization is localization, which is taking an app that you've already made all the effort and work to make sure that it fits whatever you want it to be, and making it tailored to one specific location. Means translating into a specific languages, but it also means making sure that all the weird things that you thought are completely universal, like check marks, are fitted into the local culture. In Japan, if you put a check mark, that's considered like a failure, right? That's a bad sign. Instead, they use circles to denote successful tasks completed. So if you're building a to-do app and you only have a check mark, Japanese people might not necessarily get it. Things that I didn't know before preparing this presentation. And so globalization covers both things, internationalization and then localization. So internationalizing your app, making sure that it's ready, and then localizing it for the local markets that you want to target. And now we'll go way, way down and talk about encodings, right? The very basic of displaying text on a screen. So I hope everyone here remembers and knows ASCII, or the American Standard Code for Information Interchange. It's a 7-bit encoding of how to show text on a screen. It was later expanded with expanded ASCII that doubled the range of characters that we can encode using 8 bits. For those of us who had to code with Hebrew at that time, you might remember Windows code page 1255 or IBM code page 916. It was so fun because you had a block of data that was text, and unless you knew the specific code path of that text, you might get gibberish or you might get text that you can read. Thankfully, that's no longer the case thanks to Unicode. Unicode is a standard run by a consortium to make sure that we don't have to deal with the messy parts of encoding anymore. It comes in many shapes and forms and sizes. You probably are familiar with UTF-8, an 8-bit encoding of Unicode, or UTF-16, the 16-bit part of it. This picture is really cool. This is all 1 million and somewhat code points in Unicode. And you can see the zoom level, it's pretty amazing. Probably 2/3 of that is emojis right now, but it's just all the characters in the world, and it makes our job localizing apps just a bit easier. So just to appreciate the fact that that's not a problem that we have to think about anymore. But we do. Because when we save data, we have to think about Unicode normalization. So if we look at a character like E with an accent, which is very common in French, there's actually two ways to encode that same piece of data. It could be in one character or it can be in two characters. And whenever you do searches on your database or Elasticsearch or whatever, if you don't normalize the data, you might not find matches when thinking about these more complex characters. Thankfully, a lot of languages, frameworks, databases have standard normalization code paths that we can leverage. You can think of this as doing to lower on a piece of string. You don't do it all the time, but you do it when you're going to compare strings and you're very thoughtful about it. Now let's talk about locales. So locales is the user's language and region preferences that they denote to you so you know how to present data back to them. There is a best practices 47 which defines how a tag for saving a locale is. You're probably all familiar with the very standard locales, EN for English, EN-US, English-US, but you can also get complicated and denote the difference between the American English and the British English, or even Canadian English, if that's a thing in your app and you have to be really, really hyper-specific. If you're building an app that supports Spanish, there's a generic Spanish, but then also Spanish for Spain, Spanish for Brazil, Spanish for Mexico, or Spanish for 419. Who here has any idea what 419 means? It's all of South America. So there's a way to denote these locales in the level of granularity that is right for your app. Not all apps need to support all of them, of course, that would be crazy. But if your customers are very specific about the type of text and formatting that they expect to see, you have the ability to support that. Another example is French, right? French Canadian and French are basically the same language, except when it comes to counting numbers. Very different there. Languages where it won't really matter is Hebrew. There's not a lot of customers for Hebrew outside of Israel. I think the joke is that if you look at the top 100 languages spoken in the world, we're not on the list. It's not a joke, that's truth. You can check it out. But it's not just language and region. You can denote other metadata inside the locale tag. So for example, traditional Chinese versus simplified Chinese can be part of the way we denote locale. So the first thing is deciding how do you know which locale to serve a customer. And thankfully with HTTP, we have the accept language header, which tells us what the user's preferences in their browser is, or the user's preferences in their mobile device. Now we can rely on that to make the initial decision, but the expected behavior is that somewhere within our interface, we let them change. We let them change their locale because they might be using someone else's device. They might be using a loaner computer or sitting at an internet cafe in India, and they might not be able to read the language. Next up is formatting. Formatting is how do we take binary data and show it to users the way they expect to read it. It covers a wide array from numbers, currencies, dates, and times. So for example, if we look about date formatting, there's essentially a million different ways to show the same date. You can bucket them into three main types of showing dates. There's Big Endian, which starts with the year, month, and then date. There's Little Endian, that does date, month, and year. And there's the weird way Americans do it, which is month, day, year, which, as we all know, makes no sense. Because we're developers, there is one right way to show dates, and that's year dash month dash date, but unfortunately not everyone in the world are developers, and so we have to fit their requirements and expectations. The good thing is we don't have to invent it on our own. we can rely on something called the CLDR. And that's a huge database of all the formatting options and names for things around the world. The CLDR has all the different formats for every tiny specification that you can think of for almost every locale available on the planet, which is pretty insane. So here's a tiny example from the CLDR about how to write days of the week in the Hebrew portion of the CLDR, and you can see that you have the possibility of knowing both Yom Rishon, Sheni, Shlishi, but also Yom Aleph, Bet, and Gimel, and it goes on and on and on, and so almost every permutation and option that you look for will be available on the CLDR. It's a huge XML file, and it's a bummer to parse, and that's why we never use the CLDR directly. We use either the ICU or the Twitter CLDR libraries. ICU works in Java and C++, but if we're on Ruby or JavaScript, Twitter did the massive job of getting it available for us in an easy consumable way. Now let's head to translations. So we have formatting, we know how to show dates, we know how to show numbers, but now we need to start changing strings in our interface. And most apps start with the fun challenge of having all the strings baked in advance into the code. So if we're using React and we have a render hello component, either a function or a pure component, but having that string, hello, your name, means that the task of translating it now to different languages becomes really complicated. That's where we can use libraries like React INTL, which relies on Yahoo's Format.js library, which itself behind the scene relies on something built into ECMAScript called INTL API, which is supported on most major browsers, not all of the Microsoft browsers, and also some of the older Safari iOS browsers. For that, there's a polyfill, which sort of is a hack to get the stuff working on older browsers that you can drop in and use pretty easily. So we'll do an example of translating a tiny app in React using React INTL. We start with a strings file. Usually this is a huge file that has all the different languages and all the different strings inside the app. As you can see here, I have a little greeting string, hello name or bonjour name, that can be changed in runtime. Somewhere inside the app I have in one place, hopefully in one place, the current locale that the user is expecting. So here I have an INTL provider defining the locale. Essentially, probably if this is a real app, the locale itself is in some state that can change over time. And in the component where I want to use it, I can drop in React INTL's formatted message that has an ID, which goes back to that baked JSON string file, has the values that are going to be interpolated into the string, but also has a default value. Why is that? In case I have issues with loading the locales for different languages, it's helpful. Also, think about developers reading this code without that second line of default string. I see the word welcome. I have no idea inside my app what the developer who wrote this piece of code was defining when he said welcome. But if I see hello name, I have a very clear understanding of what that translates into from the user's behavior. Another cool thing is I have formatted numbers where I can define a value, a style of number, and potentially even other attributes like currencies. And behind the scenes, it takes care of the right formatting for the right locale. The beauty of using something like React INTL versus sort of rolling out your own is the ecosystem around it. So there's a Babel plugin that will take all those default messages that you wrote and will pull them out into that JavaScript JSON file that has all the strings in it, so you don't have to do that manually each time. Rather, it will run and keep it up to date, and then you can send it to your friendly cat. And that's not the animal, it's a computer-assisted translation tool. So once you have that huge JSON file with all of those strings, someone needs to translate them. And of course, you can do it manually. If you're fluent in all the languages that you need to translate to, you probably aren't. And so usually you would use a tool like Smartling or 1 Hour Translations in order to use a wide network of different translators and have them do the work for you. Now the problem with translators that aren't part of your team is they probably don't know your code, they might not know your tone, or they might not know the different attributes or vibe that you're trying to pass through. We're currently shipping this week a new version of the WeWork app, and we had a really interesting situation about 2 weeks ago where we got a new batch of translations from our translation team, and all of the functionality to book a conference room in French said book a bedroom. Which was completely different from what we planned it to say. Thankfully, we had someone who knew French on our team who caught it before our LQA caught it. But again, using a CAT tool can help you define concepts like conference room and be clear about how we say conference room in different languages and what we mean. It can give us context, whether visual or written, about what part of the app the translator is currently working on, and also it can learn. Some tools have machine learning baked into them, so they can do a very best attempt at first pass translations before someone has to manually go in and fix or match them to actual human tone. Another really interesting point in translations is user-generated content, always abbreviated as UGC. If you're on Facebook, I'm sure you've seen the little button that says translate this post. Why is that there? The reason is, if you have a network of people who are trying to communicate and aren't sharing the same language, probably English, then giving the possibility to do a best effort translation using Google or any other online translation tools gives them the ability to join and participate in the network in a way that they might not have if the language that they have to write or read in is only the one they know. So again, an example from WeWork. WeWork has a social network built in for our members. Recently, we opened in Indonesia, and in Indonesia, a lot of people don't know English as a first or second language. The ability to give them the chance to write posts and participate in the conversations that are happening online in their native language, but have other people's more or less understand what they're trying to communicate is really helpful in building a global community. The other part that we're very familiar with is RTL, or right-to-left interfaces. This is probably the biggest challenge for anyone who's not native to this area of the world. I remember that when we were working on the PayPal app, we got a first pass attempt from a design team in San Jose trying to give us how the app will look and feel in RTL, and it was so weird. You've probably seen these interfaces where like some very excited designer starts flipping all the icons and you have no idea what they mean anymore. A personal favorite of mine is looking at these undo redo buttons in RTL and being completely scared about which one does what. So it's a huge challenge and investment, and thankfully for that, Unicode has some really good concepts baked into it about defining bidirectional boundaries. So I'm sure you've seen interfaces where you've had a string that turned into English in the middle and then went back to Hebrew, and usually it's just unreadable mess. Know that if you're planning on supporting bidirectional text and supporting RTL interfaces and languages, there are ways to denote natural boundaries between different parts of the app so you don't get those weirdness. Hello, 13, how are you? Jumpiness between numbers and text in Hebrew and English. Next up, let's talk about money. So what is money? So money is a combination of an amount and a currency. What's a currency, you ask? That's a great question. A currency is defined by a piece of information, usually encoded by the ISO 4217 standard, which has a name, a subunit, an exponent, and sometimes a symbol. Let's go through a few examples. US dollars, defined by USD, has the unit of US dollars and the subunits of cents. It has an exponent of 2, meaning that each dollar is made up of 100 cents. And we're all very familiar with the dollar symbol. Let's do shekels. Shekels, Israeli shekels, have the subunit name of agora, also an exponent of 2, 100 agorot, 1 shekel, and it has this cool, nifty symbol. What about yen? Yens have an exponent of 0, meaning there are no subunits for Japanese yen, meaning that you should never ever see in the wild any amount of money in Japanese yen that has a dot with subunits in it. But that's not all. If we go to Iraqi dinars, they have an exponent of 3, which means that 1 Iraqi dinar is worth 1,000 of fils. And so whenever you're building your app, don't hard code anything to do with number formatting or number processing, or even assuming that you have currency symbols, right? These are all the symbols, aside from like Bitcoin and Litecoin and all the new cryptocurrency that each one has to come up with the coolest logo that they can. But for actual fiat currencies around the world, these are the only logos, the only symbols that exist out in the wild. And there's many more different currencies around the world. Just as an example, Swiss franc, CHF, that's it. There's no cool symbol for Swiss francs. And when we render and format money, we have to take into consideration that each country and each locale expects something wildly different, right? This is the same amount, $3,500.50. If you're an American reading this in English, you'd expect the top row to be displayed in your interface. But if you're a French person reading French, the bottom one is what you'd expect for the same amount. And it's not just going across the oceans to see the differences. If you look at the countries that are currently in the European Union, each country has their own way of looking at money. And that's insane. This is the same amount, again, for each country and how they expect to see that same amount. And so, tip, just don't try to solve it yourself. There's the CLDR and other libraries that can help you format and match the expected output of your users. Most companies, most businesses will never ever want to build a database of their own. Unfortunately, I had the pleasure of working at a company that did need to do that. PayPal has money as its number one concern, and to support these different countries properly, we had our own internal database of different formatting for different currencies, different languages, because we needed a level of specificity that just doesn't exist outside. Also, when saving money in databases or everywhere else, just use 0 decimal concept, which means saving a flat out integer. This will help you make sure that you never end up with a amount that's illegal in the currency that you're working with. So division or subtraction or addition of money is always done on full integers, and only when you format the money, you take into account the fact that 350 cents is actually $350, while 350 yens is 350. You take the subunit, and that's what you save as a full integer in your database, instead of having decimals and having to deal with the complexity of floating and non-integer numbers. There are a few currencies that don't have a round exponent number, so it's not 0, 10, 100, or 1,000 subunits to a unit. Very rare. Most of them are not currencies that you'll actually have to interact or work with in something normal, I would say. And so I wouldn't worry about them, just know that they exist. Next up, we have text, we've translated it, we've showed it to our users in the right language and the right format. Now comes the fun part of us actually making sure that the app fits what the users want in different locations. So a part of regionalization is figuring out the unique presentation needs of the country. So an example of that, in China, you'll find QR codes on everything, everything. You walk down the road, there's a QR code on the floor, there's QR code on cars, doors, windows. When Uber first went into China, they did something very small that they thought would help them, and that's show the cars, the Uber cars, as red, which is lucky in Chinese, instead of black. It didn't help them, and in the end, Didi won that battle, but it's an example of making sure that the presentation fits the expectations of your local market. Another challenge is platforms within platforms. Again, leveraging China here because I think probably from a cultural perspective, they're as farthest from us that can be. A lot of people in China use a little app called WeChat. WeChat is not just a chat application, it actually has a full platform of sub-apps that you can install inside your main WeChat application. And so I was in China a couple of weeks ago. You can pass through border control in China with WeChat. It's insane. There's money transfers and food ordering and cabs and everything just sits within the app. So you have an iPhone and it's all fine and dandy, but you install WeChat and then you install other apps into WeChat. The same thing happens in other Eastern countries. So another good example of that is Grab in Southeast Asia, Singapore, and other countries, where the Grab app has started like an Uber competitor, but it does food deliveries now and peer-to-peer money transfers and payments in shops and messaging and so much more. When WeWork went into China, we had to rebuild part of our experience as a WeChat application. Which means that you have to know about your local market, know about the local users, and potentially make the decision of, do I take the app that I already have running and rebuild it again to support these platforms inside platforms. The last thing is the positive side of going into new markets. You can try new features that are more accepted by the local cultures. So, for example, we launched a product in China called WeWork Go that's let people pay by the minute for desk usage, using scanning QR codes in and out. And the way we make sure that no one sort of scams the system is we have a camera that makes sure and watches people when they try and tailgate, which means go past someone when he beeps into the door. Which is something that I don't know if we can pull off in countries like Germany, the US, or even Israel, with people being fine with having a camera scan their faces on the entrance to a door. Other cultures are more receptive to things like that. So leverage the fact that you're in a different country and find the things that you can pilot and try out, which you might not be able to do back home. And the last piece I want to leave you with is the concept of LQA, or localization quality assurance. This is a very complicated process of making sure that your app works and behaves in different cultures and and countries like it should for those local countries and languages. No one has solved LQA at scale in a way that's sustainable from a blocking perspective. So today you might have a piece of code that has some CI/CD process that runs the tests automatically. Maybe you check load automatically, but checking LQA automatically is not something that people have baked into their process. There's a lot of different ways that you can try and attempt to solve this. A lot of companies just end up with building the right processes to get feedback for things that are in production and look weird. For example, if booking conference rooms is book a bedroom. And one last thing that you can do as a developer to make sure that your app is ready is use a concept called pseudo-localization. And this is the idea of trying to use random, weird, long-looking strings in your interface while you're translating before you have content back from your translators to make sure that the button, the table, the title will be able to support other languages. I'm sure you've seen interfaces in German. German is on average 1.8 times longer than any other, than English, which means that if you have a button that's just barely good for the submit label, there's no way we will be able to translate it into German. And so pseudo-localization is a little trick to take these strings, make them longer, add some of this beginning and end. Anyone have an idea why we do the beginning and end part? It's not for centering, it's just because the text itself becomes gibberish at some point, and if you don't anchor it with a beginning and end, it might cut off randomly, but you will have no idea because you don't know when the gibberish is supposed to end. So usually you anchor the beginning and end, and so as long as you see the beginning and end within your interface, you're good to go. And so today we covered a bit about globalization, internationalization, encoding, translations, locales, formatting, cache, currencies, and LQA. There's a lot that you have to do, but the important thing is to take the first step, make sure that you don't bake too many strings into your UI interface, and make your future lives easier. Thank you. Any questions?